Good afternoon, I'm Charlie Ruffle and I'm the chair of the RICS Matrix Kent group. Today's presentation is on cavity barriers in masonry facades, and we've got the presenter today is Barnaby Carlick from SideRise. To hear more about the RICS Matrix Kent group, you can join on the RICS website, and if you also want to follow us on our local Yammer group or the national RICS LinkedIn group. But yeah, hopefully today will be good, and our next event is the Built Environment Curry, which is on the 17th of March in Maidstone. So bookings are available on the website already, and I'll pass it over to Barnaby.
Thank you very much, and welcome again everybody to today's session. So as mentioned, we're looking at cavity barriers in masonry facades. So there's a few learning objectives, quite a long looking list there, but there is quite a bit of content, but don't worry, it's broken down nice and digestible, hopefully. So we're going to first quickly look into some of the external wall types, obviously focusing on masonry, some of the key principles behind masonry or brickwork facades and how cavity barriers go within them. And we're going to look at some of the regulatory guidance that's out there and other guidance which helps us obviously build these buildings as safe as we can when we're looking at fire and life safety, along with which we've got some terminology and definitions which you may be familiar with already, but it never hurts to reiterate some of them because they're quite important definitions that go along with many of these terms. Then we're going to look at specifically how cavity barriers need to function within this kind of application and what essentially drives the design for us as a manufacturer as to how we make these products to fit into the application. And then obviously the very important routes to compliance, where we're looking at how they're tested to make sure that they're suitable. We've got a few slides on some important detailing which are also available as standard details from siderise.com, and a little bit about just installation and services that should be made available from all manufacturers, and a couple that we specifically do have. So just briefly introducing you to us as a company, SideRise. We, as I say, are a manufacturer of fire, acoustic and thermal materials, and we cover many different sectors within the industry. But we focus mainly on facades or construction, which both primarily are looking at facade types. However, we separate masonry into construction, as often obviously it's referred to as construction as opposed to facades like construction contractors, etc. We've actually been around for now nearly 50 years, or about 50 years, and we've got quite a long and quite interesting story and timeline that we go through, which started off as providing materials to the industry, mainly through distribution, but very quickly realizing that products needed to be far more tailored towards these applications. So ventured into bespoke manufacturing, and now we're very much in these proprietary kinds of products which are suitable for many different applications in the industry. We are a global brand. We've expanded across much of the globe, just a few sectors left for us to expand into, but primarily focused within the UK, which is where the company started and main offices and manufacturing plants still are. Very important to us are our values, and that starts off with integrity, which we've even got in our logo, as you can see in the bottom right corner. So first and foremost, we very much are focused on trying to get awareness to the industry and make sure that the products are actually suitable and best fit for these applications. And as I say, these many different values, which I'm not going to go all through of them, but they lead essentially everything that we do as a manufacturer. And what that leads us to is many different stages within the construction. So we assist with obviously education, but also very much involved in the design stages of things. So technical details, mock-ups and project-specific details, through to testing. Obviously, we do a lot of testing of the products as they are, but also project-specific system tests, etc. And then we carry on assisting once the products are actually on site with installation, training how to actually use the products and inspecting them. But enough about us. What you're actually here for today is the actual application of masonry facades. So generally when we look at different types of building envelopes or external walls, we tend to split them between the sections curtain wall or applications, curtain wall, masonry, and then ventilated or bit of a subsection non-ventilated facades. All have very different kind of scenarios, many different requirements, and that's one of the things that really drives for specifically designed products for these different applications. So focusing on obviously masonry facades today, the basic definition of this masonry build-up can be considered as a facade assembly comprising of an inner leaf, which can sometimes be a blockwork or a concrete wall, or as often is the case these days, an SFS construction. And then you'll have a cavity which will be typically filled with thermal insulation, which is obviously many different types, and things like your masonry ties, your masonry support angles, and a lot of the actual structure that's holding what's then the primary outer leaf there of the actual masonry or brickwork. And obviously a key part of what's within that cavity as well are where cavity barriers need to be. So looking at some of the key principles of these masonry facades and some of the things that we need to look out for is first and foremost, we need to close that cavity. The idea of the cavity barriers we'll go into in a bit is to specifically try and restrict that movement of fire or smoke within the cavity, or to try and stop it getting in there in the first place. So first and foremost, we need to close off that cavity with these cavity barrier products. And this is the case even if the actual cavity is fully filled with thermal insulation. Quite often you do have a gap in there, but even if it's fully filled, then you still will need cavity barriers. One exception being if the actual two leaves are 75 millimeters or greater, and both are masonry, where there are some relaxations. But the majority of the time, particularly in taller buildings, we're looking at cavity barriers within there. So this, first of all, we look at the horizontal cavity barriers, which will be probably one of the more frequent ones that you'd see on the building, being located at compartment lines, again, which we'll go into a bit more detail on locations. But the horizontal barriers can quite often be problematic, particularly with live brickwork, where they may suffer from things like push out, where often these barriers need to be compressed, and obviously the live brick's going to not necessarily want to give the resistance the barrier may need. So that's quite often can be a problem if compression is required. Being in obviously a horizontal application as well, it's not got the advantage that for verticals it does, where you've got a lot of bricks tied together. You've got a single or maybe just two courses of brick that have to resist that compression. So with horizontals particularly, that can be problematic, but we need to make sure that there's no gaps and that full gap or full cavity is sealed. You then have your vertical cavity barriers, obviously, which again will be located at compartment lines, typically where your party walls are. And again, same principles, need to be fully filling that cavity, spanning across those two leaves. And they can sometimes be more difficult where you have things like decorative areas, projecting bands of brickwork. You can have not necessarily quite a straightforward cavity to fill there. And particularly if you're looking at revisiting a building, perhaps installing cavity barriers around openings where the brickwork's already set, you quite often get mortar lumps on the back of them, which again can give quite an uneven back surface when you're looking at trying to fulfill and make sure there's no gaps. So a couple of the key principles, as I say, are to fully close off that cavity, but also it's important to bear in mind, particularly with masonry, is that the cavity must be fully drained. And that's where obviously your cavity trays and also some of the weatherproofing materials in there, or damp-proof membranes, things like that really come into their own light and have their own importance. So first of all, the best place to, when we're looking at the design of this whole application and this build-up, is looking at what kind of guidance that we have out there and what we need to do in terms of meeting regulations. Now, there's many different places to look, and one of the most important things to consider is that it's an ever-changing environment. Not only guidance or advice changing quite constantly, but also regulations can be added to or amended, and particularly true for the past few years, where there's been several changes or updates to a lot of the documents out there. So it's important to at least be aware of, if not completely familiar with, first of all, the actual regulatory guidance documents, which are based on obviously a national level across the country, or across the UK, I should say. And then following that, things like government reviews or consultations, which quite often will be the driving force behind some of these changes to regulations or requirements. So it's important to be aware that they're at least going on, even though obviously until pretty much the last minute, you don't know necessarily what's exactly going to be implemented as regulatory or requirements. You then have a lot of guidance coming from industry itself. So many different directions, such as bodies, advice bodies within the industry, insurers, main contractors, consultants, many different directions, and of course even manufacturers. So some of this guidance, whilst it may not be regulatory, it's always a good idea to be at least familiar with, because ultimately it's going to be forming that best practice. And quite often it does also get upgraded and implemented into requirements, perhaps not as quickly as things like consultations or government reviews, but often they do wind up into regulatory documents. So with all of these different kind of guidance directions that are out there, it's very difficult to keep on top of it all. So at least having a bit of an awareness and perhaps subscribing to some of these construction news sites and things like that, which gives you updates, is always a good idea. So getting a little bit more into detail on some of this guidance or requirements that are out there. As I said, first of all, we have the national documents, which differ depending on which country within the UK we're looking at. So for England and Wales, we have approved document B, slightly different variations for the two. So you can see there the green version, which is England, and blue for Wales. You then have the technical standards, volume 2 for Scotland, and technical booklet E for Northern Ireland. Now, whilst all of these different documents are specific to obviously where they're located, there are a lot of similarities, if not probably more similarities than there are differences between them, certainly when it comes to the regulatory requirements. One of the first things that's similar or very much the same between all of them is the function of a cavity barrier. What job does it need to do? And that is, as defined there on the screen, and that's directly quoted from approved document B for England, a construction within a cavity other than a smoke curtain to perform either of the following functions: to close a cavity to stop smoke or flame entering, or to restrict the movement of smoke or flame within a cavity. So the reason why that definition is very important is it's telling us that the whole job of that cavity barrier, that product. So that's going to immediately tell us where they need to be located and what they need to actually do in these locations, which we'll go into a bit more detail in a few slides' time. Now, within many of these guidance documents, as I say, they are guidance documents, not necessarily regulatory in their entirety. There often are parts of regulations quoted within them. So again, very much taking the approved document B for England largely through this presentation, you'll see within the approved document text boxes which have a green background, such as the one on the right there, and these will be regulatory sections, so they are quoted from the regs. And there's a few parts that we pay particular attention to when we're looking at protecting facades, and specifically masonry facade types. So the first one, very quickly to look at, is Regulation B3. And what this does is it sets out the requirements for a few key terms there. So fire resistance, compartmentation, subdivision and fire suppression, and then cavity barriers and fire stops, which will go into what they exactly mean through this presentation. We then have Regulation B4, which, as you can see, is a much shorter section, but it's essentially highlighting the importance of protecting against the spread of fire and smoke the external walls and any roof of a building. These are often seen as some of the primary routes for fire to spread, and if the fire actually takes hold of a facade or a roof, it can quite easily bypass other areas inside that building or measures within the building. So it's of utmost importance to protect these elements from that spread. Regulation B4 does also introduce one of the newer regulations that have come into play, which is Regulation 7, and that deserves a slide on its own. Now, Regulation 7 is quite a complicated regulation, but it is fully enforced. It came into play in November 2018, and it must be followed, as obviously being regulation would suggest. Now, what this regulation is about is essentially a ban on combustible materials within external wall assemblies. And there's multiple parts to it to explain exactly how to go about that. Going in actually reverse order there, part 4, first of all, is defining what's called a relevant building. And a relevant building is any building that this regulation applies to. Now, a relevant building is defined as any building which has a story at least 18 meters above ground level and contains one or more dwellings, an institution, or contains a room for residential purposes, excluding rooms in hostels, hotels, or boarding houses. Now, going back to where I was saying it's important to keep up to date with these consultations and reviews, bear in mind, just with this very definition of a relevant building, there's a couple of key parts that may be changing or are likely to change as soon as March this year. The first one is the 18 meters. That may well reduce and is likely to reduce to 11 meters come March. And then another part, which is that exclusion of rooms in hostels, hotels, or boarding houses, that may also actually then be deleted or omitted, and reintroducing that kind of building type or use as a relevant building. Now, the reasons for that, quite simply, are the 18-meter rule has always been based on the ladder lengths, essentially, of the fire brigade. But it's true that actually most engines now carry 11 or 12-meter length ladders, not 18 meters or 19 meters. So that 18-meter rule, hence, is being reduced to that 11. Interestingly, that's one of the differences in Scottish regulation is for their ban on combustible materials, their relevant buildings are actually already at 11 meters rather than 18. Now, things like the exclusions of hostels and hotels and boarding houses, the reason why originally they're excluded is because reasonably they would have quite active fire strategies in place. They would be staffed 24/7. So in the event of a fire, there should be not just any automated systems, but also staff on site to assist with the evacuation of the building. There would always be an evacuated building in the event of a fire. And things like having plaques on the back of the doors or leaflets or training as to what to do in the event of a fire. But I think it's very true to say that not many of us will actually be taking the time to read all the plaque and leaflet information when you've had a long day at work and you're checking into a hotel. So that being quite reasonably a reason why they may be actually reintroduced, is you can't necessarily rely upon these. So that's what a relevant building ultimately is. Now, going back to the start of it, part 2, this ban on combustible materials is very specifically a ban on materials that don't have a reaction to fire rating of Euroclass A1, which is non-combustible, or A2 S1D0. So that's the line where the differentiator for this regulation is concerned between combustible and non-combustible materials. Now, bearing in mind that with these external wall build-ups, it's not always possible to actually achieve that kind of fire rating or reaction to fire rating and still function primarily as the product that they're meant to function for. So part 3 of the regulation actually gives a list of exempt materials, which you can see on the right box there, in brackets 3, and then a list of A to J of different types of materials. Now, whilst they're exempt from that A1 or A2 S1D0 rating, they may still have some minimum requirements, which I'll highlight some of those later on in the slides. So it's important just to double check within the regulatory guidance documents what exactly is going to be required for that project. There is a couple of sort of consequences of this regulation as well, relating to routes to compliance, largely around large-scale testing. That, again, I'm going to leave to the actual compliance part and the testing bit when we go a little bit more into what exactly these tests are, and I can expand upon the reasons why this has an impact on them. Some other sources of important guidance that it's certainly worth being aware of out there are particularly from bodies such as the Association of Specialist Fire Protection, or the ASFP, that have a lot of advisory notes and guidance documents for best practice or sort of the safest way to build these buildings. You have the CWCT, again, with many standards and advisory notes, but then also there's a lot of and there's too many to list ultimately, but a lot of different providers such as the NHBC, which will have their own design guides and requirements. But you can have that same with from not just warranty providers or building control, but also from insurance providers and from main contractors and sort of specifiers. And then obviously there's a lot of other sources out there, such as the FIS and the RICS authority. So it's very important to, again, be aware of these different guidance documents that are out there. So quickly looking at some of the important terms and definitions that are out there. And again, apologies if you're already familiar with what they may be. But one of the first things to really distinguish the difference between is reaction to fire and fire resistance. Now, ultimately, what we're doing is we're looking at exposing a product or a material to fire and seeing what happens. But they're two very different types of testing. So reaction to fire, just as the name suggests, is all about seeing how the product actually reacts when it's exposed to that fire. All materials will eventually break down when exposed to fire. And the important thing from testing reaction to fire classification is to see how severely they break down, how quickly they break down, and what kind of volumes of sort of debris or smoke that they produce as they're breaking down. So with reaction to fire, we're splitting them into different categories as to essentially how reactive they are, how much they're going to contribute or not contribute to that fire. Whereas with fire resistance, what we're looking at is, again, exposing the products to fire, but this time we're looking at how good the product is at blocking it. So rather than what it's doing and what it's producing, but actually how well it stops that fire from transmitting through it. And there's a couple of different criteria that go along with that. So with regards to reaction to fire, as I say, it's broken down into many different categories. And this is done through certain standards to what's called the Euroclass system. And with the Euroclass system, you have a class letter, and that ranges from A to F. And A actually splits to A1 and A2. And then afterwards, if it's anything from A2 or more reactive, so down to class F, you then also are declaring a couple of criteria, one which is smoke production and one which is flaming droplets. And the rule of thumb essentially is the earlier in the alphabet the letter comes, the less reactive it is, and the lower the number, the less reactive it is, or the better. So class A1 is deemed as very best in terms of reaction to fire. It does not react, it's deemed as non-combustible. If it's not quite non-combustible, then you do have that secondary class A there, as I say, class A2, and that's deemed as limited combustibility. And this is where we start, as I say, splitting to a couple of those key criteria. So smoke emissions or production is always defined as the letter S, and then can be rated from 1, which is little or no smoke, to 2, and then 3, which is obviously most amount of smoke. You then also have flaming droplets, which is denoted by the letter D, and that rates from 0, obviously being 0 droplets or none, all the way to 2. So with that ban in Regulation 7 on combustible materials, bear in mind that just because it has A1 and A2, it doesn't mean any A2 material. It specifically has S1 and D0. So you could have an A2 material that isn't S1D0, it could be, say, S2D0, and that wouldn't be suitable. So it's why it's important to declare these little criteria there that go along with different materials. Another thing that popped up in Regulation B3 was compartmentation. And again, you may be very familiar with compartmentation or the idea behind it, but what compartmentation is essentially trying to achieve is splitting the building into smaller sections to then limit that spread of fire and smoke. So inside the building, usually you'd have that as your apartments or could be certain rooms. They'd be split into compartments, little zones or separate spaces. And that would then give you an idea that you should have whatever fire rating has been required for that project. It'll take that long before the fire can then spread to the adjoining rooms or compartments, and then again repeat for the next spread. On the outside of the building or the facade, it's still important to try and maintain this compartmentation. As I mentioned before, otherwise that facade could enable for the fire to spread past or beyond that compartmentation within the building, and then actually bypassing fire measures and spreading far quicker. So even though with masonry application, where we have quite specifically a inner leaf, which is forming the difference between obviously inside and outside the building, because we have a cavity between that inner leaf and that masonry, that could form a space that could allow for the spread of fire and smoke. So we need to protect at compartment lines wherever we have those cavities spanning them. Now, in terms of just jumping a little bit back to in terms of the definitions, as we've already been through what defines a cavity barrier specifically, bearing in mind that it is designed for these cavities, it's not necessarily inside the building like a fire stop material. And quite often cavity barriers or fire stops, the terms get thrown about or mixed up. Whereas you can see on the far right there, a fire stop is a very different kind of product where it's all about maintaining compartmentation within that building. So if you've got a gap between two walls that are compartment walls, or a floor and the back of an external wall, then those would be fire stops where you need to maintain that compartmentation. Whereas a cavity barrier is that product again that we're looking at to fit within the cavities, and they may be located at compartment lines, but they're there to try and restrict and slow that spread of fire. So they've actually got a slightly separate requirement there. Now, something that you may come across not that frequently within masonry, but it does sometimes get utilised, are what's called open state cavity barriers. And these are cavity barriers just as before. However, they have the allowance to allow for ventilation and drainage in the cold state. So they utilise intermeshing materials on the front face of the horizontals, which means you have an open gap through that cavity, but in the event of fire, that intermeshing will react, expand, and then close off that gap, regaining compartmentation. So you may come across those barriers occasionally. Now, going on to fire resistance as opposed to reaction to fire, fire resistance is then measured by three key criteria. First of all, you've got the resistance to collapse or load-bearing capacity, which is denoted by the letter R, and that's specifically for anything that is a structural element or a load-bearing element. So things like your floor slabs, your columns, your roof, that would be obviously a load-bearing element. You then have the actual resistance to fire penetration, or what the ability to stop the fire getting through that product, and that's denoted by the letter E, known as integrity. You then have the resistance to transfer of heat, so the actual insulation of that product, and that's denoted by the letter I. Now, when we're looking at cavity barriers and fire stops, we're looking just at that E and I, that integrity and insulation ratings, and that's because they're not load-bearing elements. A simple way of looking at integrity is, as I mentioned before, just its physical ability to block that fire from spreading. So taking that little diagram in the bottom left there, if you had two rooms next to each other and one fire in one of the rooms, but you had a hole in the adjoining wall, you could put a product in that hole or over the hole, and if it's got a good integrity, then it's going to stop that fire from spreading into that next room. And that's what integrity is all about. It's how long that product will physically stop that fire from spreading into that next compartment or room. Now, the important thing, and why we also look at insulation as well as integrity, is that going back to school physics lessons, hopefully you all can remember the fire triangle, where for a fire to actually occur, all you need is fuel, oxygen, which the room would have obviously oxygen in, and may have boxes of paper or furniture or carpets in. You've got your fuel. The only thing you're missing is heat. So if that fire is able to not necessarily get through the barrier, but the heat of it's able to transfer through, then you can get spontaneous combustion on the non-fire side. So it's important that when we're testing cavity barriers, we're not just preventing the fire, the actual flame getting through, and also the smoke, but also we need to make sure that not enough heat is getting through it to start a fire. And that's what the insulation in terms of testing cavity barriers is referring to. Now, in terms of just temperatures, to give you an idea, bearing in mind a typical office or residential fire would within 4 or 5 minutes reach temperatures of roughly 1,200 degrees Celsius, which is obviously a horrendously high temperature. In terms of the integrity and insulation, the insulation part, we're making sure within testing that no more than 180 degrees Celsius is ever being transmitted through it. And that's based on one of the lowest temperatures for spontaneous combustion to occur, which typically is paper at about 200 to 230 degrees Celsius. So still certainly wouldn't want to be in a room where 100 or more is getting through into it. That is very hot, but in terms of a fire, that is a very low temperature. So that's the sort of ballpark figure that you're looking for, 180 or below, to achieve insulation on these products. So now looking just at a few of the more specific performance requirements. Now, firstly, the regulatory guidance documents set out the actual time requirements for cavity barriers specifically. So again, as I say, this is where they differ from fire stops, which need to meet the compartment lines ratings. So for England, Wales and Northern Ireland, you have a requirement of 30 minutes integrity and 15 minutes insulation. Slightly different, however, with Scotland, where you actually have 30 minutes integrity, but no requirement there for the insulation. And that's largely based off the idea that there shouldn't be any combustible materials within the cavity that can actually start combusting from spontaneous combustion. Now, bearing in mind that these are minimums set out, there's often reason to actually increase on the project what kind of requirements there is, or fire resistance there is. Sometimes that's led by industry misunderstandings as to what it needs to be there, a fire stop or a cavity barrier. But more often you'll find it's from fire engineering approaches, upgrading because of a fire risk factor, or an occupancy kind of factor. So things like hospitals, often you might have increased requirements. But also there may be times where cavity barriers need to be omitted or moved, and that may also increase that risk of fire. So increasing the performance of them or the surrounding ones may alleviate that. That's not the only reason, however. You may have things like warranty providers or insurance providers, or even builder or specifier client specific requirements may be set out for higher requirements there. So it's important to be familiar with on the project any of these specific requirements for it may be outset, usually fairly early on in the design stage. Now, in terms of locations, we've essentially explained already where those locations need to be. We need to try and stop that fire from spreading or restrict it from spreading within the cavity. And we've talked about compartment lines. So you can see there from diagram 9.1, that's in approved document B, volume 2, the English version. Zoomed in there, you can see a little bit better. Within the two leaves of that external wall assembly, we have a cavity barrier in line with that compartment floor. And then the same is true, obviously, vertically. You'll have a cavity barrier in line with any party walls. But to try and stop that fire from actually getting into the cavity in the first place, we also need to look at protecting around openings. So at the heads and sills, and also vertically the jambs of windows and doors being the most common, but also quite often will extend to things like ductwork, which may be cutting through that inner leaf into the cavity, or maybe even all the way through to the outside of the building, or outside of the outer leaf. So it's important to figure out where these openings are or what's being considered as an opening, as they'll likely need sort of framing around, as you can see in that diagram there. Sometimes they can be grouped together, like you might find vents just above windows, or just offset slightly. That can be encapsulated in sort of one frame as such. But that again is where fire engineering comes into play, and sometimes requirements may be increased. You do also need to protect, again, around the edges of that cavity. So usually, bearing with me that the diagram there is obviously of a traditional build with an apex roof. More so if you had a flat roof with a parapet detail, there may be requirements for a cavity barrier within there. And then again, things at the bottom of the cavity, which unfortunately doesn't zoom in on there, but you can see on the diagram. So surrounding essentially wherever fire could break into that cavity, and that includes the edges. Now, another important part that's brought up in regulation B3 and about restricting the movement of fire within the cavity is subdividing what's called an extensive cavity. Now, anything greater than 20 meters between two cavity barriers is defined as an extensive cavity, and that can be vertically or horizontal. But so bear in mind with that sort of diagram there, if I go to the next one, you can see it a little bit easier, is say, for example, you had an elevation here which was a single apartment and that was 30 meters wide. Even though there may not be a party wall behind the wall along this elevation, or may not be a wall at all of its open plan, because the distance between these two cavity barriers on the corners are greater than 20 meters, it means you have to have an intermediate barrier somewhere, reducing that to 20 or less. And that's true for anything where essentially you're using a thermal insulation that is a class A1. If you're using anything less than that, then that can actually reduce to 10 meter centers. As mentioned before, there's also some other guidance out there. A very common one that you'll see is the design guide from the NHBC being utilised. And with Masonry, they actually very much follow suit in terms of what cavity barrier locations of where the regulations require them. It does interestingly actually have an increased requirement when you're looking at cladding or ventilated facades. Now, the CWCT have quite an important or quite a useful technical note, note 98, which essentially goes through much of what we've been through already, defining a bit better perhaps than the regulatory guidance documents, some of the requirements like compartmentation and locations of cavity barriers and fire stops. So now looking at the actual drainage of that cavity, as I said before, a very important feature of masonry facades. What we're typically looking at there are cavity trays within that cavity, and then also DPCs in front of vertical cavity barriers. So you should always be looking at cavity trays above horizontals, as I say, those DPCs in front of verticals. Important to note as well, within that regulation 7, one of the exempt materials are cavity trays, but only if they're used between 2 leaves of masonry. So with this ever popular build-up of having an SFS inside, it's actually required to have a class A1 or A2 S1D0 cavity tray within that cavity. So again, another important thing to consider. With regards to dealing with some of these uneven walls that we've looked at, there are many different applications or different types of unevenness and different sort of decorative bands and things. But one of the things that I also mentioned before are these open slate cavity barriers, which is one of the products that we actually supply called our EWI product. And it's essentially an intumescent barrier, which then can be either friction fitted to the back of that masonry or actually stepped away from the back of it by up to 25 millimeters. So obviously, depending on the manufacturer, what products they may or may not do, will determine the exact sort of dimensions. But the idea behind this kind of barrier is if you were to say have a couple of bricks that then protrude outwards, rather than having to notch the cavity barrier to then fill in that gap that's filling or formed at the back of the facade, it allows you just to keep that cavity barrier as is, and as long as it's within that dimension of the intumescent expansion, it can fully fill that gap in the event of a fire, making labour or installation far easier and quicker on site. So now getting on to the actual routes to compliance, some of the important bits. I mentioned before that Regulation 7 has had an effect on routes to compliance and specifically large-scale testing. It's something that's not typically as common within masonry applications, but you can actually do large-scale system tests such as the BS 8414 test with a masonry facade. And historically, if you had tested to this large-scale test standard and got a pass certificate, you could register it as a BR135 system. And then that would essentially be your route to compliance. So it'd be signed off by virtue of being tested at system level. However, with Regulation 7, that overrides any sort of essentially pass marks where it may involve combustible materials. So in other words, regardless of whether you've got a compliant BR135 system, it now has to also comply to Regulation 7. But as I say, masonry, that's not as common as it is perhaps in things like cladding. So typically the route for compliance would be making sure first and foremost, do the actual products comply with Regulation 7? And then if yes, the test certificates and reports would typically be supplied to the project fire engineer and submitted for evaluation or approval. And then that would be your proof of compliance that you can then continue to build as designed. Now, the component tests for these, as I say, there's many different types. But firstly, when we're looking at reaction to fire, there's a standard that you can see there, the N13 or 13501 Part 1, which outlines various different testing schemes that you need to comply to get your Euroclass ratings. As I mentioned before, depending on whether it's a relevant building or not will determine some of these materials that you can use. So specifically in there, if it's not a relevant building, then things like the cavity trays, there's no minimums, and most of the materials there, as you can see, that there isn't actually minimum requirements. Whereas if it's a relevant building, the cavity tray with an SFS does then become an A1 or A2 S1D0. But also things like the membranes, which before didn't have a minimum, and whilst they don't need to be A1 or A2 S1D0, these do still, as you can see, have minimums such as Class B S3D0. So it's just important to be aware of some of those minimums, even if they may not be that non-combustible or limited combustibility. Now, with regards to fire resistance, a common question that's asked is that the products are tested between two leaves of aerated concrete. And the reason you do that is when you test for fire resistance, you're trying to test what the performance of that product is, be it a floor, be it a wall, be it a cavity barrier or a fire stop. And you don't want any of the bounding elements to limit what performance you're going to be getting out of that test, because you want the test report and the results and the data to show exactly what happens to it throughout its entire performance ability. And that's why the standards are drawn up to test in that way. And that enables engineering judgments to be made. It's a way that you can then prove compliance with the regulations, the requirements for cavity barriers and fire stops, and also enables third-party certification of products. Now, it looks like a very daunting flowchart there. I promise you it's not once you realise what's going on. Basically, for the shape of the slide, it's in an L shape. So this is basically pointing towards direction generally of what kind of test standards you required depending on the application. So very quickly and simply, when we're looking at cavity barriers within a masonry application, first of all, we should always be primarily looking for EN standards. British standards are an alternative route of testing now rather than primary. And then, is it a cavity barrier or fire stop? We now know it's a cavity barrier. Is it open state or closed? Well, we know they're closed state barriers typically that are being used. So we're looking at this EN 1366 Part 4. If they were open state, then we'd be looking at a different standard because, as I say, they're not commonly used. So primarily you'd be looking for this standard here. What exactly does that standard look like? Something a little bit like this. So essentially you've got your products then installed between aerated concrete. With masonry testing, what you can quite fortunately do, and what we tend to do, is you can see there's actually a masonry leaf there and then block work behind it. So if masonry does have an impact on that fire test, it will be observed within it. And also that sort of black thick line you can see there is actually a DPC installed between the fire stop and that masonry. So it gives us data to prove that we can use our cavity barriers with DPCs as well. As I say, that other standard, the TGD 19 for open state cavity barriers, is quite a different kind of test. And what we're looking at here is the function of that intumescent as well. So you can see there, it being for horizontal cavity barriers, you've actually got an air gap and quite a different tested arrangement there. And that's all about testing the actual intumescence function as well as the core of that cavity barrier. In terms of system testing, as I say, not very common, but can be done for masonry. We have the 8414 test, which, don't worry about this, is just a repeat of the previous one in terms of routes to compliance. But looking at system testing, as I say, primarily you can go 8414, either parts 1 or 2, part 1 being the block work in a leaf, part 2 an SFS. The 9414 there as well just essentially gives guidance as to how you may extend that field of applications. Excuse me. So you can see there is quite a different kind of test, these system tests. You're involving all of the different components, and apologies, it's pictures there of cladding as opposed to masonry. But as I say, it's very uncommon truly to actually test to this size with masonry, as it's seen as a far more robust type facade type. But you can, as I say, test to them, and what you're doing is you're testing all the different components, such as any supporting structure, your thermal insulations, there are your cavity barriers, and then whatever that outer leaf may be. Now, what all this test data leads to is, once as a manufacturer you've tested these products or your products, you can then go for third-party product certification. And what third-party product certification is essentially a way of policing and monitoring test data. Because the reality is, when you go to a test facility, and it being third-party UCAS accredited laboratory, it's been tested third-party, but what you get provided with is just a test report. Now, in a test report, it's essentially a lengthy document full of data. You've got time temperature graphs, you've got product descriptions, you've got observations as to what happened. Not very often does a test report actually say whether it's passed or not. So this is where certification comes into play, where quite often led by the test houses themselves as well, being full of obviously fire engineers. But what they'll do is they'll take the test data, and that can be often from multiple tests, product samples, any technical information and manufacturing specifications of that product. Then they'll analyze that all together and provide a certificate which will give you your field of applications, what that product's intended for the use, and what kind of performance it gives you, how it's installed, things like that. And then that certificate will have an expiry date, unlike a test report, which doesn't, it's valid forever, it's just data. And that certificate will then, as I say, have an expiry date, but during that lifetime of the actual certificate, which can be up to 10 years, it will actually be continuously audited. So regardless of, because it's been third party, if there's any changes to the product manufacture, supply chains, anything like that, they should be declared to the certification body. But even if they weren't for any reason, they will be picked up very quickly, and then either the certificate may be withdrawn if they think it's going to make a difference, or you retest before you actually implement those changes and then submit that as a proposed change to then be included within that certification. So third-party product certification gives you, as a consumer of these products, peace of mind that that product is going to give you that performance it did when it was tested for the lifetime of that product being manufactured. So it is, as I say, it's a good peace of mind, and really thoroughly recommended, particularly in things like the Hackett report, and generally in industry, to look for third-party certification. Now, slightly different from third-party product certification, you then have third-party installer certification. Now, this has nothing to do with us manufacturers. This is down to the actual contractor that's installing. And FireAS, we have no affiliation with. It's just probably one of the primary types of third-party installer certification schemes that are out there. So this text is all just copy and pasted straight from their website. You'll see it directly from there. And the important thing that I'm just highlighting from here is, whilst it's a very good route to proving competency of the installers or the installation company, as said by FireAS themselves, this last line here, FireAS certification is awarded to the contracting company, not the individual employees. So what that essentially means is that the company itself is being certified, and it's got to follow obviously what the certification scheme outlines in requirements, and it is constantly monitored against those, but it's not necessarily training the individuals how to use the products. So not to sort of contrast with, but quite the opposite, to go hand in hand with third-party installer certification, we recommend or suggest that manufacturers should be providing training on their products as well, to give the actual individuals themselves that training as to how to use the products on site, and then how to make sure that they've been installed correctly. So that hand in hand with third-party installer certification should give you the documentation and that added peace of mind, which, especially when coupled with the actual product certification, should give you a very thorough documentation on a product that is suitable and has also been installed by competent people and to a good standard. So it's quite long-winded, but all of that sort of service and that sort of documentation should be provided by manufacturers and installers alike. Now, very quickly, conscious of time, just going to skip through a few details. As I say, they are all available on our website, so you're more than welcome to have a look and download. But these standard details essentially are highlighting just some of the important little differences that you come across. It's not always just a nice rectangle hole that you put a rectangle block into. Often you've got a lot of different variances in there. So things like supporting structure, your masonry support angles, they are always on the compartment line, that floor slab edge. So they're always going to be typically in the way of the floor, the cavity barriers. So again, one of the things that we take upon ourselves to do is test with the actual cavity barrier being penetrated by that masonry support angle. So we actually test with the cavity barrier being 100% cut through by masonry supports to make sure that it doesn't have an impact on the product's performance. Things like cavity trays, so making sure that any sort of cavity trays on the market should be like generic sort of stainless steel ones are suitable. But we have also, if this is of interest, not necessarily fire product, but we have developed our own non-combustible cavity tray or our A2 S1D0 cavity tray, which is formed of a mineral wool, just like the cavity barriers themselves, and it can sit on top of the cavity barriers or be freestanding within the cavity. But it's something that then complies with that regulation 7, and obviously is far more compatible with cavity barriers or our products sometimes than some of the other offers out there. Things like DPCs, as I mentioned before, we have tested with DPCs, so we've got test proof that they're suitable and they don't have an impact on the test on the fire performance of the products. Where you may have balconies being added to the outside of that building, so these sort of either bolt-on or slip-on balconies, you've got quite significant balcony support structure coming out, these big beams or studs coming out from the actual building. We do have cavity barriers bespoke made for surrounding them, packing them, and a couple of different types. So one which fully fills and one which boxes around. And that means rather than having to do any complicating detailing with the cavity barrier, you quite simply abut it into the side of the cavity barrier that surrounds that balcony bracket. So within the masonry offer, we do have a very significant offering there for all these different products, as you can see, all of which are backed up with test data and have third-party accreditations with them. And finally, on details, just mentioning one of the advisory notes from the ASFP is always just be wary when you're looking at mixing and matching different products. It's generally not recommended, but also there's obviously a lot of bodies that say for specific materials, like for example, horizontal and vertical cavity barriers, you shouldn't really be mixing different manufacturers' products as they may not be compatible with each other. So very lastly, just as I said before, and I've already really gone through, in terms of the installation, we get heavily involved in that design stage, helping with all these details, project-specific, standard details, obviously giving general advice and testing information. In terms of training, we have a lot of collateral available, again, all available on the website and also supplied with the actual product on site, such as the quick guides, to make sure that hopefully they get installed right. But to make sure that they do, we offer free of charge training, which is actually third-party accredited, our training program, as it doesn't just involve coming and giving a talk to the installers. We actually do a classroom session. We test the installers, make sure they've been paying attention, and then we won't actually issue the certificate of attendance until we come back, say, a week later, and we audit the products that they've been installing to make sure that they have absorbed that training and are utilising it with installation of the products. So obviously we also do inspections either in person, or we can offer our app, which is free to download and to use, and you can essentially carry out a checklist, take photos, and then submit that report to us, which will review and provide advice or stamp to say it all seems to follow our guidance from what we can see. Last couple of slides here are just summaries, so I believe these slides will be made available for you. So these are just some summary notes that might be handy if you wish to acquire the presentation, and also to use those. There are some case studies. I'm not going to go through these, don't worry, even though the marketing department will always gets angry at me for skipping them. But there's some nice case studies there showing just some of the key projects we've been involved in. And then some links there to some of the key advice or guidance that we recommended at the beginning. You'll be glad to know that's the end of my dulcet tones and the end of the presentation. There are our contact details, but you should also be able to access those as well through the event. So that is the end of the presentation. Thank you very much for listening. I hope that's been of some help.
Thank you, Barnaby. That's been great. Just so you're aware, there's a few questions on the group chat, so I'll pass you back over to Barnaby and Simon. But thank you very much for your presentation.
Thank you. Right, my name's Simon. I'm a colleague of Barnaby's, and there's a few questions that's come into the chat, which we're going to look at now. One of them is regarding how easy is the product to be used on retrofit. I think one of the largest sectors in the marketplace at the moment is obviously reclad work. Now, our barriers, I'm not saying they're easy, because obviously trying to make space in a brickwork to insert a cavity is very difficult, but it is an application that is widely used in the industry. And the main reason is because of all the penetration details that you'll often get in reclad work compared to a new build. So yeah, it's a viable option for reclad work, definitely.
We're also always happy to provide advice in terms of which may help with sequencing. As Simon says, we quite often do see even masonry applications which are being revisited, where you may sort of cut out sections of block work. One of the advantages as well with the system that we have is, or the couple of systems we can offer, is if it's quite troublesome getting or satisfying that you're getting a full fill in that actual application, is things like the horizontal open state barriers, means that you've got that guarantee of, as long as it's the air gap's no greater than that 25 millimeters, even though there is a gap, it will be filled in the event of a fire. So things like that, and the normal just our EW barrier, you don't need to compress. So on sort of, if you're having to re-brick up straight in front of it, it will not push those bricks out because there's no compression on it. And again, that's fully tested.
Thank you. Next question. This is for you to answer, Barnaby, I'm afraid. Do you think there will be changes in the legislation to the requirements for cavity barriers between sleeping compartments in the same demise?
Yeah, often you'll have a cavity barrier requirement, obviously, at party walls. I'm guessing by that you mean as well between things like if you had multi-occupancy apartments, things like that, especially student accommodation. It's something that's been visited on and off. I don't know that there's any significant moves towards sort of splitting up individual, say, apartments and student accommodation and things as of yet. But we have certainly seen an increase on actually putting cavity barriers in between, say, kitchen areas and the rest of the apartment, things like that. So ultimately it comes down to the building specifically and the parties involved with that project. Sometimes it can, let's say, be from the client or insurer or the main contractor, especially in terms of increasing requirements from that minimum 3015. We see a lot of that happening already. But they tend to come from industry, not necessarily from regulation. So if people are already doing that or following that suit, it wouldn't be necessarily a rushed thing into regulation, because you don't need to convince people. Obviously, they're already doing it, but it may well do. So sorry, that's quite a vague answer, but hopefully that makes sense.
Right, there's another question. I should be able to answer this one. Where there is a material change between render and cladding, do you include a cavity barrier in both systems or just the one? Where you are looking at a scenario like that, you've got to treat them as a separate zone. One, because the way the cavity barriers will work for a render system will be different to the way it works for a cladding system. So you would have more than actual one cavity barrier there. So I hope that answers your question. There's another one as well. Can you briefly discuss installation and how the units are fitted? I'm not too sure what that is for or what section. If you want to elaborate on that, Charlotte, that'd be appreciated. Sorry. Next one, what materials are used in our barriers? As we mentioned before, it's a mineral wool base product for our core material. And obviously, and the next one is, do you use a combination of your barriers with intermissants? Our core material stays the same. And then we only use an intermissant on our EWI product, and our RH products are the only ones that have got the intermissant strip on the front. Lovely. Any more? Oh, some more have just coming through. Right, next question. Where there are already mineral wool cavity barriers installed to a cavity and they aren't fully filling the cavity, i.e. they aren't thick enough, can you fit an open state barrier to that gap, bearing in mind your comment about not mixing and matching different materials? Literally, as you said, you can't mix and match, so you wouldn't be able to add to it. So that product would need to come out and be reinstalled correctly. I hope that answers your question. I'm just going through any more that I can see coming through. Yeah, we will obviously, if you always look on our website, there will be links for further guidance as and when they come through. So obviously regularly visit our website, you will see links on our site. Right, there's another one coming through. Right, please do you ensure the impact of your product installation actively on project time is reduced? Obviously, different fire barriers have different installation procedures because of how they've been tested. Are ours quicker than others? In certain applications, definitely yes. But obviously, it's all project specific in relation to installation times, and obviously a save on the project time is reduced or not. So it more is, as I said, project by project basis. Just double checking I haven't missed any. Right, this one for you, Barnaby. Does the product act as a waterproofing product against adverse weather?
It's not a waterproofing product, but it is water resistant. In terms of the product itself, if it does get wet, we do have some ad hoc data in terms of it being completely submerged. But the product itself, being stone wool, it's non hydroscopic, so it doesn't absorb water like a sponge. It naturally actually repels it. So it will always naturally dry out itself, and as long as it's sort of, bearing in mind obviously if it is saturated, it will become a bit heavier. As long as the foil faces haven't been torn off and things like that whilst it's wet and being handled, if it's say in situ and gets wet, it will just dry out naturally. There's no problem, you don't need to change it out or anything. In terms of it stopping water getting through it, it won't do 100%. So if you're looking at it particularly, say for example, as the fire stop inside the building, say behind a curtained wall, and you've got people at the end of shifts sweeping puddles directly on top of the fire stop, as unfortunately is all too common, the fire stopper itself, it will let water through it, but very gradually. It'll be a very slow drip. So if you are looking at situations like that, or you do need a full water seal, then there are products where you can sort of countersink the fire stop or cavity barrier slightly and then use them directly above, usually a sort of self-leveling seal, which will give you a full tanking seal. You can always improve the product on its own just by using things like the foil tape that's used for joints between abutting lengths against the facade and substructure. But generally it won't give you a full tanking weatherproof seal. It's not really designed for that.
Right, I've got clarification regarding the question in the installation of our products. Our products are held back to the substrate with either galvanized or stainless steel brackets. Our standard products, i.e. like your CW or your EWs, are the brackets are secured to the substrate using a single non-combustible fixing, and then they penetrate the product itself around about 75% way through. Where you're looking at products with the intermescent strip, because obviously there's an actual void there for letting it vent, they are positively retained using our galvanized or stainless steel brackets to obviously positively retain them in position. I said the subsequencing is always our vertical, are always our primary fire barrier, followed by horizontal. So very straightforward and simple installation. Charlotte's asked another hot topic question regarding lead times. Up until 2 weeks ago, we were on a 5-day turnaround from place of order. Subsequently, at the moment, we're on a 5-week turnaround. There is a big issue with supplying and getting raw material to our manufacturing site at the moment. Right, another question. What's the average lifespan of our cavity barriers? Well, all of our barriers have got a 60-year warranty on them for life expectancy on all of our range. Yeah, obviously, just so you're aware, there's another question regarding our material. ROC will manufacture our material to our formula in regards to, so we cannot, as you said before, regarding third-party testing, we cannot just get our raw material from anywhere. It has to be from one source because that's the product that has been tested, whether that be third-party or whether that's our, obviously a large-scale or single-scale testing. So we can't mix and match our product.
The important thing as well with the core material that we use is it's not an off-the-shelf kind of grade of material. We very specifically have manufactured just for us a very low resin and additive content grade of stone wool. So again, it's quite different to what you might find from other products.
Yeah. Another question coming through. Yeah, all we do is provide the cavity and fire barriers and the obviously cavity trays. We don't actually provide a facade system itself.
But we are happy to work with facade manufacturers to come up with a design together to assist you.
Yeah, I'm just double checking. That looks like all of the questions that's come in. Yep, no more. So that looks like we have hopefully answered everybody's questions. If not, then we're happy to, obviously, if you want to send them in later, not a problem at all. We're always here to assist you. So, thank you very much for your time. I hope everybody, stay safe and well, and hope to see you on the next one.
Thank you, Simon. That's great.